Problem number 1792, maximum average pass ratio. There is a school that has classes of students and each class will be having a final exam. You are given a 2D integer array classes where classes I equals pass and total. You know beforehand that in the ith class there are total students, but only pass number of students will pass the exam. You are also given an integer extra students. There are another extra students, brilliant students that are guaranteed to pass the exam of any classes they are assigned to. You want to assign each of the extra students to a class in a way that maximizes the average pass ratio across all the classes. The pass ratio of a class is equal to the number of students of the class that will pass the exam divided by the total number of students of the class. The average pass ratio is the sum of pass ratios of all the classes divided by the number of classes. Return the maximum possible average pass ratio after assigning extra students. Answer within sections will be accepted. Okay. So you want to maximize the average pass ratio across all the classes. Let's first check the range of the classes and its pass and total numbers. Okay, class length will be at least 1. Class length will be equal to 2. Okay. Okay, pass and total will be at least 1. So it is all positive integers. Okay, then let's see, for this example, like, where can we okay, another extra student. Okay, so yeah, we must add the extra students to the classes. Okay, so for the pass ratio for the classes now, it is like, yeah, it is this is 0.5. This will be 0.6, and this is 1. So added to the last, yeah. Yeah, I am thinking, like, is there a best way to follow to add the students to the class? Or like if we add, yeah, I'm thinking if we add the students to the least pass ratio, like if this is 0.5, then we add it to this class, then it will be, yeah, then it will be 2 divided by 3, and this will be still 5. this is 0.6. This is still 1. Yeah, since if we add it to the highest pass ratio, it doesn't work. Like this is still 1. It will not that the average pass ratio grow. So and add it to this. Like if we add 1 to this, it becomes 0.666 like this. And if we add it to the middle one, it will be 4, 6, and it's like it's the same, but this has a greater, like added to the least one has a greater growth. Okay, and then we still have 1 extra student. So yeah, like which class should we add? The first class or the second class? If we add it to the first class, it will become 3, 4. And if we add it to, it is and if we add it to the second class, it will become this. So add it to the third, the first class will be better. So I think it's not is it like I think it's because the first class has less students, so when adding a pass, like 100% pass student, it can bring more effectiveness. Yeah, and like the second class, it has much more people, so adding one pass student will have less effectiveness to the ratio. So I think we should select the total students, like the last total students. So when not only last total students, but we should look at the ratio and we should look at ratio as well, and we also need to look at its total students. Like, okay, so if we first look at the total students, then this 2 is less, then we should look at its past students. Or maybe first select the last total students and then select the last past students. How does it sound? Okay, maybe let's try this class. So it has 4, so for each, so now this has less students, so we will add 1 to here, so it will become 3, 5. And then 5, 5 will add this as well. So the next it will be 4, 6. And then 5 will be the next, so it will be 6, 5. Oh, sorry. It will be 5, 6. And now both are the same. Let's select 5, 7. And let's see how the ratio becomes. Okay, 5, 7 will be 3 plus 9 and 4, 5, 5, 6 plus 10, 10, 4. Not really a good one. Okay, maybe or is it better to like to have the maximum possible average ratio? Maybe add it to this first since it has the least pass ratio of the class. Then it will be, but yeah, like it will be 14, 11, 3. But for this it is, yeah, but if we change it to 5 and 3, this is still 10 and 2. Yeah, it's better to give it to this. Okay, so when the same, or maybe we should calculate like it's added. I'll say when added by 1, what is increase, the pass ratio increase. So first of all, it's 0.5, but increase it will become 0.6. Yeah, and this is the second one will be like this, and it will increase to 0.4. And this is 0.8 will increase and the other will be 0.2. It will increase to we always select the largest one, like yeah, that who has this one. Okay, so I think we will look through the extra students, and we will have a HIP to maintain this margin. I'll say margin, is that correct? Like the difference. And yeah, so we will have okay, so first for the extra student, and so for the HIP, we want to, yeah, we would like to compare its okay, so we want a max HIP, with key equals to next ratio minus current ratio. And yeah, I'm thinking what else information we need for the HIP. for every node in a heap. We will first have we'll make it like this, and then next and current. So next time when we so next time, like, and when replace here, we will do we will replace, it will become the current will be current next, and next will be we need its I think we need its students, past students and total students. So I need these two values. So I'll have I think I'll have current total. Yeah, like total and past students. So it will be current total plus 1, past plus 1, current ratio will be total plus, next ratio will be plus 1 plus 1, so this will be negative. This is, I think this will be better. So okay, let's create the heap. Let's say for class for pass, for P and total in classes, I want the current P, the current total, and this ratio, this difference, it will be P plus 1 minus total plus 1 So then we will, after creating hip, the next thing will be calculating the output. That will be, or we can wait till we can wait till all the calculation is done. So every time we'll have max hip. So hipify max hip, and or maybe we'll have ratio. And every time there is an extra student, that's hip replace max ratio, and we want the largest div is popped, and it will replace to a new tuple. It will be current is div pass total. So I want a new, if we select it, it will be the current total will be total plus 1. So the next new div will be p plus 2. P plus 2 minus P plus 1, the current. And then at the end we can sum, we will calculate its average. So average I will say sum of the ratio and divided by length of classes. The time complexity will be big O. Now this is n. Simplify is n, so n plus n. And for each extra student, let's say e, it will replace, so e log, there is n plus n in the sum. Okay. We can optimize this sum into this for loop, so we don't have this n. We can, for an implementation, I will do like, we'll first have ratio sum equals 0, and we will do this for loop. And we'll have also n equals length of class. So ratio, I'll say ratio banded or maybe enumerate. I think I will do ratio append this stuff. And I will have this an empty array, and then we can calculate its ratio sum at the same time, so it will be P total and after this we will simplify the ratio, and then we will start our assigning extra students. So every time we replace max, we have to modify our sum. So ratio sum has to minus P total and plus the new one. Then for this we will have ratio sum divided by n. Okay, then we can remove the n.